today we are talking about regression and line of best fit. So when you're looking for your line of regression, you are looking for the line of best fit. So you are trying to see what kind of function fits your graph or your data the best. And so we're going to do this in Desmos. If you don't have the Desmos app or you don't have Desmos on your computer, you will definitely want to download that or pull that site up. And again, that's just regular old Desmos calculator. So what we're going to be doing is looking at some graphs, and we're going to look at word problems. When you're looking at graphs and you are trying to pick some points off of it to type in your calculator, for linear, you need 2 points. For quadratic, you need 3. Exponential, I think you only need 2. We'll see when we get there. So if it is a linear, you know that it is going to be a straight line like this here one we have on number 1. And that regression model that you're going to type in Desmos is Y with a little tiny 1. And when you type Y1 into Desmos, it will automatically make it a little sub 1. And then you do this little squiggly. And then it's M x1 plus B. And that's just your regular old slope-intercept form for a linear. And the Y1 and the X1 will be where you'll type your table in, and that's where they come into play. If it is a quadratic, so you know that is a parabola, so it looks like this, number 3, then your regression model is Y1, squiggly again, and then it's just standard form of a quadratic, so A x1 squared plus B x1 plus C. And then the exponential one is Y1 squiggly A times B. And then the X1 is actually in the exponent for that one. And then your exponential graph will look like this one here at number 2. And so if you know what the graph is, like in these first 3, then what you're going to do is you're going to make a table, and then you type in either the linear, quadratic, or the exponential down below it, and then it will give you the equation, and you just plug in for the coefficients. So the y and the x, they're just going to stay y and x, but you plug in for like the m and the b, or the ABC and the other ones. So that is if you know that it is linear, quadratic, or exponential. If it is a word problem, or maybe you just have a table of values, you'll want to find which of these is best. And so to do that, you're going to look at the R squared value. So in Desmos, it automatically shows you R squared. If you're using a calculator, if you're on the ACT or something, you do have to turn it on to where the R squared comes on. And so to do that, you go to, you hit second 0, which takes you to the catalog. And then you scroll down to where it says diagnostic on. And then you turn that on. So again, that's if you're in on a regular calculator. But if you're in Desmos, again, it shows that the R squared value to you automatically. And so what you're wanting is this R squared to be close to 1. So if it is 1, then that means that the graph, that the model fits the graph, or it fits the table 100%. It is a perfect match. If it's like 0.99, then that means it is super, super close. But when you start getting down to like the 0.7s, 0.6, 0.5s, those sort of things, that means that it's really not the best representation of your data, whether again it's a graph or if it's a table. So if you're trying to choose which one is best, you enter your table into Desmos, and then you want to type in all three of your linear, quadratic, exponential, of course it depends on the problem, and see which one has an r squared that's closest to 1. So we'll look at that in a minute. So first let's just find the equation of some of these where we do have the graph. So if we look at number 1, what we want to do is we want to make a table. We know by looking at it that it's going to be linear, it's just a straight line. And when that's the case, you only have to have 2 points. You can have more, you can have as many as you want, but you only have to have 2. So I've got my 2 points here already marked. One is at -1, 0. And then my other one is at 0, 3. So we're going to type that into Desmos. So to do that, you want to click on this little plus sign, and you click Table. And then if you look there, it says Y1 and X1. So those are the same Y1 and X1s that are in our little formulas up here. So you want to make sure when you have your table that it says X1 and it says Y1. If it doesn't, you can actually change those numbers. So like if you wanted it to be Y2 for some reason, you could change it, but you always want it to be X1 and Y1. So for our table, we have -1, 0, and we have 0, 3. And you can see it'll plot those up here. And then down below it in our second line, again, we know that this one's linear, so I'm just going to type in my linear model here. So Y1, gotta cancel my HBO subscription. Okay, so we got Y1, and then if you click on the ABC, right here down in the bottom is that little squiggly, and then MX1 plus B. And then you can see that it'll graph it, and it goes perfectly through those points. We can see here we've got our r squared value is 1. So again, it matches 100%. It is a perfect fit. And then you can see your parameters. It tells you that m is 3 and b is also 3. So when you write the equation, you just take those and plug them into the equation. And again, you just leave y and x as they are. So our equation for this function would be y equals 3, because again, 3 is our m, x plus 3, because that is our b. Okay, let's look at our next one. So our next one, number 2, this one is an exponential. So again, I'm going to find me some points on here. I have a nice one right here. So that's at 0, 1. I have another one right here, which is at 1, 2. And then we'll do 3 just to do 3. And so we have another one at 3, 1, 2, 3, 4. So instead of entering in a new table, because again, you want to keep this as y1 and x1, I would just say always edit this table. And then you don't have to worry about if it says y1 or x1. It always will, because you're not going to change it. So in this one, we got 0, 1. We have 1, 2. And we have 3, 4. But we know by looking at this graph that it is an exponential. So I'm going to type in my exponential model. So y1, squiggly. So again, you click ABC down here at the bottom. A times B. And then in the exponent, you want x1. So if we look at this one, the r squared is 0.98. I'm not sure why it is not perfect. Maybe our little graph here wasn't. Maybe it's not exactly at 1, 2. It looks like 1, 2 is the one that is off a little bit. But that's okay. So it's close enough. So if we look down here, we've got the A is 1.2. B is, we'll round that to 1.5. And again, we want to plug in for that A and that B. So y equals A is 1.2 times B, which is 1.5, to the x power. Yeah. So I took out that middle point and just did the 0, 1, and the 3, 4, and that turned out a little bit nicer. So it should be 1. That A value is going to be always your y-intercept when you have an exponential. So our exponential here, again, it should have a y-intercept of 1. So that 0.12 must not be exact, even though it looks like it on our paper, but that's okay. We're close enough. Okay, one more with a graph. So on 3, we know that this one is a parabola, so that means it's going to be a quadratic. For a quadratic, you have to have 3 points. So you can have 2 for linear, you can have 2 for exponential, but you have to have 3 for a quadratic. And again, we have our little dots here, so we'll just use those. So we have -1, 4. We have 0, 3. And we have 1, 4. What that was. Okay. So let's type them in. So we have -1, 4. We've got 0, 3. And 1, 4. Again, it's going to graph them for us. And then it's quadratic, so we want to type in our whole quadratic. So y1 squiggly, ax1 squared, plus bx1, and you definitely want to make sure you have the 1s on both of those x's, and then plus c. Again, we've got our r squared of 1, so it's a perfect fit. And we've got A, B, and C. So our A is 1, B is 0, C is 3. So again, we just want to plug those values in. So y equals, A is 1. So you can write 1x squared, or remember you can just do x squared because there's always an understood 1. B is 0, so I could put 0x, but again, anything times 0 is 0, so I don't really have to. So I just need that plus c at the end, so plus 3. And that's it. So if you're given the graph, it's pretty simple. You know which of our 3 regression models to use, find your table, type them in, and then you're done. So let's look at one where we have to decide which is going to be the best. So let's look at number 4. So number 4, we want to find a linear and an exponential model for this data. Then we're going to see which one fits best and why. So first we want to type in our little table here. I'm going to get rid of quadratic because I don't need it right now. So in my table, again, you can close it out and then add a new one. Just make sure again that it says x1 and y1. So I've got 1, 5. 4, 7.5. Oh, nope. 6, 10.2. 10, 18. And 12, 25.3. Okay. And then again, we want to know which is going to be best, linear or exponential. You can kind of look at this one and tell, but we'll type them in and see which one has a bigger r squared. So our linear is y1 squiggly mx1 plus b. So that one has an r squared of 0.94, so that's pretty good. Let's check our other one though. So y1 squiggly a times b, and then in the exponent x1. So if we look at this one, our r squared is 0.9986. So we've got a linear is 0.94. Our exponential is 0.99886. So we can see that that exponential is the better model, again, because that r squared value is closer to 1. So let's write our exponential model. So we've got a, so y equals, our a is 4, we'll round it to 4.1, times b is 1.16 to the x power. And then to answer the question why, we'll just say the r squared value is closer to 1. Okay, so now in part B, we want to use the model to predict y when x is 10. So to do that, all we're going to do is take 10 and plug it in for our x. So y equals 4.1 times 1.16 to the 10th power. And then we can just type that into Desmos. I'm going to leave my models because we're going to need them again here in a minute. So we've got 4.1 times 1.16 to the 10th power. And we get 18.08, or we'll round it to 18.09. And so if we look, that's our y value when x is 10 using the model. If we look at our table, when x is 10, y is 18. So they're super close together. And so that tells you that this is a pretty good model. So let's look at C. So C, we want to use the model to predict when y is 30. So we can do 30 equals 4.1 times 1.16 to the x. Now we can solve this by hand. I know that we haven't done this in class. You should have done it in Math 3. But we will do this later on. For now, though, we'll use Desmos. So if we look at our table at 12, we're at 25.3. So we know it's going to be above 12. So what I'm going to do is look at my graphs. And I know that my green one is the exponential. So I'm just going to scroll up to where y is 30, which is here. And I'm going to see what this x value is. So to do that, you just click on the graph and hold it. If you're on your phone, if you're on the computer, you just click on it with your mouse. And scroll up to when y is 30. Hopefully we can get right at it. Oop. And that might be the closest that we're going to get. So it's around 13.2-ish is when our y value is going to be 30. So x is about 13.2. Okay. So when you're wanting to find the y value, you can just plug that in, type it in Desmos. When you want to find the x value, though, look at the graph and see when y is 30, what is x? And hopefully it'll be pretty close. Okay, one more. So in this last one, we are looking at the number of insured commercial banks, which is our y in thousands in the United States from the years 1987 to 1996. And x represents the number of years since 1987. So that is super important. So if we look at this table, we have the year, we have the y, but it tells me that X is the number of years since 1987. The most important part when you have years like this is you never type these actual years into your calculator or into Desmos. You always want to turn them into years since something. So in this one, it's 1987. So we're going to say 1987 is our year 0. And then our next year is 1988. Well, that's 1 year later. 1989 is 2 years after 1987. 1990 is 3 years after. And then etc. We can keep going. So 1991 is 4, 5, 6, 7, 8. And then 1996 is 9 years later. So when you have a word problem, anytime that it is years, you want to change those years into actual numbers. And it'll say, usually it's whatever the very first number on the table is. So in this one, it's 1987. So what we want to do is find a linear, quadratic, and an exponential, and then decide which one is the best fit. So to do that, we want to start by entering in our table. I'm sorry, but I got to cover it. Wondering. Yeah. So see how I closed it, and now it says X3 and Y3. I don't want that. Please don't play music. Of course it's going to.